Hello everyone, in this video we're gonna discuss guest networking, which in SEAPATH is done with OpenVSwitch and of course Ansible and playbooks. So if you want to have VMs discussing with each other on a virtual bridge, it's pretty easy. What you have to do is explain what you want to have in your OVS inventory. So basically it's the OVS bridges object that will detail everything you need, everything you want, your topology, everything you want in OpenVSwitch. Don't forget to set this ignored bridges variable to team0, which is the cluster networking. We don't want the guest networking scripts playing with the cluster networking. That would be bad. In our example, we'll have two VM, which are Debian and Debian2, so two guests, really basic Linux VMs, and they are going to run on. So Debian is going to run. I don't see it, so we don't know. There is no constraint, but Debian2 is going to run on Virtual 3. So anyway, it doesn't really matter where the VM runs because of VXLan. So the idea of VXLan is that we are going to extend the bridges from one host to another throughout the cluster networking that connects all our nodes. So the idea is when you create a bridge, let's try this bridge, for instance, bridge just whatever the name. We configure different ports, two ports, which are the next and the previous port, and they will extend this bridge from one host to another through VXLan. You just define a key, which is a number. With only those lines, the bridge will be available to any node, plus to any hypervisor, I should say, because only the hypervisors are having this OVS bridge topology, but they're going to be on any node, and they will be extended, so connected one bridge to another through the cluster networking. So this topology is going to be pushed on the servers to a configuration file, a JSON configuration file. So basically the same data that you see here using YAML will be here using JSON. So basically you retrieve the same, you recognize the same ports, etc., etc. There is no, the port we want to create to make our VM discuss are not created for now. I'm going to do it right now. So let's just check. Deb1 doesn't exist. Deb2 doesn't exist, so we don't have any ports. Once the ports have been pushed on this configuration, there is a service that will apply this configuration to OpenVSwitch. And as you can see, there is pretty much nothing right now. So we hope that it's going to work when we create. So already created that. So we are going to create one interface per VM. So there are 3 VM. We're going to test only 2, but we're going to create the 3 interfaces on this bridge. Which one? Which bridge are we going to? On this? Yeah, on this bridge. So BRPO, which is extended using VXLan. So those interfaces are going to be created on each and every one of the hypervisors, but the VM is going to connect on, of course, the one it's running on. So you got to make sure before you apply the networking playbook. So there is a variable somewhere in the cluster playbook, the cluster inventory, that says whether we should apply the configuration or not. In this case, the configuration is set to be applied, so the networking playbook will try to apply the configuration to OpenVSwitch. If VMs are running, it might prevent the playbook to restart the service that applies the configuration. So if you modify the topology on a host, make sure no VMs are running on that host, which is the case here. Let's apply the playbook and see what happens. So that's the service that's restarting. It seems to have been working. So if we run the OpenVS show now, so first we're gonna look at the configuration and look once again for deb1, deb2. Okay, so now we see the interface are there in the BRPO bridge, and if we check the actual OVS configuration, OpenVS switch configuration, we can see the interfaces out there. So now we're gonna make the VM use those interfaces, and that's how you do it. So you create an Ethernet interface, not managed because it's already created by OpenVS switch, and you just link this already existing interface to a specific bus. So in that case, it's a bus 2. And if we go to the Debian 2 system, can we also check that? Yeah, so it's also linked to the second slot, and it's deb2.1. So now that everything is done, we are going to run the VM. So let's start VM Debian, and let's start VM Debian 2. Okay, so the VM are starting. Debian is running on Virtual Labo 1, so we should see it here. Yes, and Debian 2 is running on Virtual Labo 3, so we should see it here. Great. If they have been booted correctly, we should be able to connect to them using SSH. There they are. Up, not yet, this one. Maybe wait a minute. Yeah, okay, now it's fine. And if we run the interface, we said this was a slot 2, so we have ENP0S2, which is linked to, like I said, the deb interface, this one. We can see it's up, deb11, so this interface is linked to this tap. And of course, if we do it on Labo 3, we should see that the second one is up, because, okay, this interface is linked. Okay, they're not on the same bridge, they're not on the same IP addresses, but they should be able to communicate together. So, because like I said, the bridge are extended using VXLan. So, if the IPs are correct, if the networking layer is fine, I should be able to ping the second one from the first one. And it's working. Of course, it will be working in the other direction too. And that's how you make gets communicate through OpenVS switch and VXLan. I hope this video was instructive. Thank you very much.